Hi, everyone. Welcome, and thank you for making the time to join the AWS for Industrial session. My name is Dan Banga. I am the head of product strategy for machine learning at AWS AI. And today I have the pleasure and opportunity to talk to you about some of the challenges and opportunities for industrial customers of ours and how analytics and artificial intelligence can help, and how Amazon AI is building products and services in order to assist some of our customers. At Amazon, we've invested in the last 5 or 6 years building services for artificial intelligence from an end-to-end perspective. And we started at the bottom of a layer with addressing the needs of extremely challenging customers in the sense of their ability to play and deal with machine learning depth. So from that sense, we work with data scientists, we work with research scientists, we work with developers to figure out how to build the tools, the processes, and the services to meet their needs. And we've been going up the stack in terms of simplifying access to machine learning for every developer. Over the years, we managed to make TensorFlow, MXNet, and the deep learning libraries more accessible. We managed to build machine learning services in the middle of the stack in the name of Amazon SageMaker, which I will talk about slightly later. And as of recently, we've also been building what I call purpose-built services that really tap into industries and they tap into customers' needs from the perspective of their current domains and needs. And so in that sense, I'd love to talk about what we're doing in the industrial ecosystem. And as you all know, Industry 4.0 is an industry term that promises what we call the fourth revolution of industrial. And some people call that industrial Internet of Things. Some people call that connected things. But the way we see it is really using data and analytics to solve some of the deeply challenging problems that some of our customers are facing in manufacturing, transportation, logistics, agriculture, power and utility, and so on and so forth. These are data-heavy domains. These are sensor-heavy domains. And these are real field domains in the sense that you have to get to the manufacturing plant and connect to different protocols and different assets in order to be able to ingest the data or even access the data before you start figuring out how to put analytics on top of it. So talking to customers, we have observed and classified some challenges that they have. And you may know better challenges, you may know other challenges, but this is a simplification and a summary that comes from some of the conversations we've had with customers. First of all, you need to access data. And accessing data is not easy because there's hundreds of machines with different communication protocols that are on premises and that need to be connected to. They speak different languages, they have different sensors that are adapted for communicating with these machines. And it's a real challenge for our customers to connect all of these assets to the cloud in an organized and structured way. The second thing that happens when we've connected to the data is that we need to read in the data and structure that entire data set. Data management is a challenge because data comes unstructured. It comes sometimes in streams, it comes sometimes in batches, and it comes in different file formats. And it's a key challenge for some of our customers to put that together in an organized manner before doing analytics on top of it. The third thing is that the scale at which we operate, or scale at which our customers operate, essentially having to connect fleets of services, having to connect fleets of machines, is really a problem. And maintaining the status on all of these different assets on the field, again, in an organized manner, it's a challenge. So I'm going to dig into the details. But before that, let's talk about some of the key customers' needs across industrial workloads. Number one is engineering and design. It's really important for everyone running a business to accelerate their time to market. What we see talking to customers is that they want to lower their infrastructure costs and improve collaboration in order to leverage experience and expertise and accelerate the time it takes for them to get to market. The second thing is that production and asset needs optimization. User experience is key, and what we see is that it's increasingly important for our customers to create new revenue streams, to lower the cost and increase the efficiency of the current assets that they are using in order to maximize some of the return, or in order to optimize some of the metrics that are important to them. And AI can help with all of that. Quality management is important, and we're going to talk about that in details later. Worker safety is also a domain where we're talking to customers, and AI could help with essentially ensuring that workers that are working on the manufacturing plant or on the field are safe. Supply chain exists, it exists in every domain and industry. And there's also different ways that artificial intelligence is plugging into supply chain, essentially improving forecast and accuracy, reducing inventory costs, and then improving capacity utilization in order to, again, optimize a certain metric that is important for our customers. And it's usually maximizing returns in certain ways. With that, and with the time that we have, I thought it would be useful to essentially look at use cases for industrial customers and talk about some of the products and services that we have recently launched that help our customers address these use cases. The first one that is very common is improving assets performance and reducing unplanned downtime. The second thing that we're going to talk about is automating visual and quality inspection for some of the assets that exist in the manufacturing or in the industrial ecosystem. And the third thing that we are going to talk about is improving operational efficiency at the edge using computer vision. And the fourth thing that we're going to talk about is forecasting the demand and managing inventory within the context of supply chain. Let's start with improving assets and performance by reducing unplanned downtime. The goal for many customers that we've talked to recently is to get to the phase 3 of what we call optimized environments, which is essentially achieving anomaly detection, and by detecting, diagnosing, and predicting all types of anomalies that could affect some of the machines that they're running. So anomaly detection is very important, and diagnosing that using AI tools and not having humans in the process is one of the key challenges for our customers. And as a matter of fact, it will save customers about $630 billion by 2025 if they do implement predictive maintenance appropriately. So the potential of getting a machine within the maintenance schedule by anticipating and diagnosing and predicting an issue is aggregated to about $630 billion. And it could happen in many ways. It could happen in preventing failures and downtime and so on. It could happen in minimizing the risk by using some predictive methods. It could happen by optimizing inventory and resources. And it could also happen by essentially predicting the lifetime of an asset on the field and leveraging machine learning, ordering or getting procurement in time in order to replace the asset before the asset dies, essentially, on the field. Amazon Monitron is an end-to-end system that has sensors, gateways, and devices, and a mobile application. And the way it works is very simple. In a matter of minutes, you can put a sensor on either a gearbox or a motor or a pump or a bearing, and Monitron will be able to detect vibration and temperature. And from there, Monitron would send these signals over to the cloud, and it does two things once the data gets to the cloud. The first thing that it does is that it would learn what is the normal behavior. And the second thing is that it will learn from the normal behavior what is the variation away from a normal behavior. And with that, Monitron will be able to detect anomalies and send notifications to a mobile app that is also available as part of the service. And so it's really easy to connect. You just place Monitron onto an asset, and again, that could be a gearbox, it could be a pump, it could be a motor, And in a matter of minutes, Monitron will be connected and ready to go. And we use Monitron in our own environment. This is an example of an Amazon warehouse. You can't see it, but we do have Monitron devices right there, capturing vibration and temperature and alerting some of our warehouse managers as to some of the challenges that could come up there. And as a matter of fact, I'm going to play a video right now where Amazon employees talk about their experience using Amazon Monitron.
The volume plan for this building is really close tied to the max machine capacity we can run through the systems. So meaning every downtime of at least half an hour or 50 minutes will cause a lot of packages which are somehow piling up somewhere in the building.
So Amazon Monitron we will be used mainly on the conveyance. We have 26 kilometers of conveyance in this building, and that's got to be running at all time in every corner of the building.
At the moment, around 1,000 of these senders are just located all over the conveyance system in our building. And the first couple of days it's learning. So it's learning how the system is running, what is the normal temperature of a motor, what is the normal vibration of it. And every deviation is directly alerted via our warehouse management system to our ME technicians. And they can just go there and have a look.
We have an indicator and sensor give us the signal. We have a defect motor, so we saw the temperature was very high. The team make the decision to exchange the motor before we have an outage, and we can work together with operations that we set up a maintenance window in the right time and to make sure that we have no impact on the customer impact.
The next thing that is related to Monitron, I talked earlier about an end-to-end system which includes sensors, it includes analytics, it includes the end-to-end perspective. And that's not the end of the story. We decoupled the brain of Amazon Monitron from the sensor itself and the device, and we created the parallel service called Amazon Lookout for Equipment, which is essentially the brain of Amazon Monitron available to some of our customers that have their own sensors. We do recognize that within your ecosystem, you might have your own sensors that detect temperature and vibration, and it takes no machine learning expertise to connect your own sensor to the same capabilities that are provided by Amazon Monitron onto the cloud by using Amazon Lookout for Equipment. Again, it automatically trains machine learning model on your unique sensor data. It learns what is the normal behavior, what is the health of a certain equipment, and it analyzes the next or the incoming sensor data automatically and alerts the field and the team if there's an anomaly that is detected. For example, GE Power is a leading provider of power generation equipment, solutions and services. GE operates many manufacturing sites around the world in which most of the manufacturing equipment are not connected or no monitored for health. And GE uses Amazon Monitron to connect some of their assets to the cloud without the need of deep technical expertise or without the need of machine learning or without having to configure their own IoT or over-the-air networks. So essentially, it's super quick and easy for GE to start monitoring their assets using Amazon Monitron. The next thing that I'm going to talk about is automating visual quality inspection using computer vision. The way it happens today is that customers do manual inspection on production lines. They do end-of-line inspection, or they do inspection offline in order to detect defects and in order to remove the assets that have a certain defect. Machine vision is a domain that is promising the ability to essentially detect defects semi-automatically, but it doesn't come without challenges. One of the first challenges that comes with machine vision is the ability to create the data that is required in order to detect the defect. So with that, you have to access sufficient amount of images to produce that have defects in them. You need to train machine learning models in order to learn what these defects are. You need to run the machine learning models at scale in order to capture some of these defects and alert the team. And then you need to maintain some of these machine learning models in order for them to learn over time what are the future defects that could come within the ecosystem that you manage. And so talking to customers, we created a service that is called Amazon Lookout for Vision. And Lookout for Vision is essentially a simple service that can detect defects using computer vision. It improves defect detection, speed, and consistency and accuracy by basically comparing good quality images with defectors quality images. It takes no machine learning experience. All our customers have to do is to load a set of images. And what Lookout for Vision would do is learn from the reference images and labels, and then automatically detect, create a machine learning model that is unique to the customer and unique to the data set that is provided by the customers. A customer of ours that is very happy with Lookout for Vision now is Dafsgaard in Sweden. And Lookout for Vision doesn't always have to be used with images on the manufacturing line. This is one of my favorite examples where a customer uses Lookout for Vision to identify defects on pizzas, for example. And the rate at which Dafsgaard makes pizza goes to about 100 pizzas per minute. And because Lookup Vision is a service that essentially gets an image and returns a yes, no, good, or bad answer, it's very quick and easy for Dashguard to detect whether a pizza doesn't have a certain item on it. For example, doesn't have a certain topping that is required. The next thing I'm going to talk about is improving operational efficiency at the edge using computer vision. And some of the challenges that come when you have to use computer vision at the edge are things like low latency. It is important, speed is important, for example, in the case of worker safety. It is super important to be able to detect whether there is a scenario or there is a case where a quick answer or quick rescue should happen. There's bandwidth constraints because some of the assets that are on the field don't have enough power, they don't have enough internet connectivity, they don't have enough bandwidth. So it's always challenging to figure out how to make machine learning models small enough to live within the assets that exist on the field, and that doesn't come without challenges. The other challenge that comes within that ecosystem is processing data on premises. Again, with a limitation on power, with a limitation on the capacity of the machines, with a limitation on storage, with a limitation on speed, it's super challenging to figure out how to have a bespoke edge computer vision solution that is flexible, that is cost effective, and so on and so forth. So what we set out to do was to create a service called AWS Panorama. AWS Panorama is an appliance that essentially adds computer vision at the edge for our customers. And the next thing that Panorama does is that it will analyze the video feed from multiple cameras in the field and generate a highly accurate computer vision prediction within milliseconds. So it's essentially that gateway between your cameras on the field and the cloud that understands how to ingest data from the camera, send that over to the cloud, train the machine learning models over in the cloud, and then download the model back to the field, and from there, provide the high-speed predictions that are required. And Panorama also comes with what we call the Panorama Device SDK, which is essentially a software development kit that makes it possible for our customers to use their own intelligent cameras that can run a specific software and communicate with the cloud in order to, again, send video streams over to the cloud and then generate predictions and so on and so forth. What we are doing at AWS Panorama is that we are creating a set of sample code and sample APIs and sample applications for use cases such as PPE detection, such as safety zones detections for some of the workers that work on the field. And we also have customers such as Fender using Panorama to essentially improve the visibility into the metrics that they need in order to spot the bottlenecks in the field, in order to optimize efficiency that they have on their end-to-end operation on the will talk about within the context of supply chain is Amazon forecast. So forecasting the demand and managing inventory is important. It's very vital for some of the services, essentially, if you want to optimize your revenue streams and if you want to delight your customers. And there are many ways to look at supply chain optimization and or forecasting use cases. One of them is managing the availability of your product and inventory. The other one is finding opportunities to lower the price of your assets and delight the customers. The third one is looking for opportunities to essentially deliver goods faster and cheaper to your customers, and optimizing routes, optimizing other aspects like customers' needs, customers' preferences, and so on and so forth. So forecasting has multiple domains and applicabilities. With Amazon Forecast, what we've set to do is to create an end-to-end service that does accurate time series forecasting. What Forecast does is that it ingests time series and applies a series of machine learning algorithms that were created by Amazon scientists. So essentially, it's an entire pipeline and set of algorithms that ingest, train, and deploy machine learning models on behalf of our customers, but the customers still maintain control and security requirements. Foxconn is an example of a customer that within the global electronics manufacturing ecosystem, and they leverage forecast to increase the demand forecasting accuracy by 8% on their resources utilization. The last service I'll talk about very briefly is Amazon SageMaker. So all the services that I talked about earlier are managed services that essentially bridge the gap between the no machine learning experience and the end-to-end production use cases that some of our customers have. But just in case our customers have their own data scientists, they have their own expertise, they have use cases that are not really fit for managed service, we have Amazon SageMaker, which is an end-to-end machine learning service that builds, trains, deploys machine learning models at scale. And it's integrated with a development environment that is geared for machine learning development that our customers use for ad hoc machine learning development, for research and discovery, and for implementation of custom models. And with that, we've worked with a number of customers to essentially solve problems in the computer vision ecosystem, within the healthcare and pharma manufacturing ecosystem. We've worked on demand forecasting use cases for retail. The last thing that I want to talk about is a promotion that we have using Amazon Monitron. Amazon Monitron, like I said earlier, is an end-to-end service which is fairly new, and it does end-to-end monitoring of assets on the field using machine learning on the cloud. And I'm happy to announce the discount codes on Amazon.com and Amazon Business that you can leverage to essentially order an Amazon Monitron kit today. To learn more about machine learning at AWS for industrial services, go to aws.amazon.com, events/Hannover Messe. Thank you, and thanks for your attention.